This is about antiderivative. Okay, we did this kind of similar questions previously, okay? It's called antiderivative. Antiderivative, so let's see here. The antiderivative and the derivative is the opposite operation, okay? So if you say f prime x, this guy's derivative is fx, then the antiderivative of lowercase fx is the capital case fx, okay?
Okay.
Yeah. This guy is just like saying, this guy is just saying, hey, this guy derivative is this. If you want to get this guy derivative, you go to the original of capital case fx.
Oh,
all right?
Okay.
So now let's see here. We know that if function f has an antiderivative capital Fx, then there is a family of functions which share the same derivative. They will differ only by a constant c. So listen, look. Yes, if you have a function fx equals to lowercase fx is 3x squared, you might see that if your fx is x cubed, right? F cube derivative based on the power rule, that's 3x squared, right?
Oh, yes.
Okay. And what will happen if you say fx equals to x cubed plus 5? Look, your derivative for the exponential part, it is 3x squared. For the constant part, it's always 0, right?
Yes.
Oh, so you notice that if you want to look for your fx, you not only need to write down this, you also have to write down a capital C. This is a capital C means constant term, which means you can do a vertical shift up to any constant values. Your derivative are the same. All right?
Okay.
They ask you explaining the meaning of capital C. You just say that's a constant term in fx because constant value derivative is 0. Make sense?
Yes.
Okay. Now, give each derivative below. Find the general antiderivative by guess and check. Now let's do this. So the capital Gx, please guess, and then we check. What do you think?
X squared plus C.
That's beautiful. Or B, go ahead, check. Guess and check. You might want to put a coefficient in front, okay? Yeah, go ahead, try it. What do you want to put? You want to put what? You want to try t cube, right? but you want to put a 1/3 in front, correct?
Oh, okay.
That's the trick.
Okay.
Yeah, I'm going to teach you this trick. Okay, so here, follow this rule. Whenever you have this derivative equals to a exponential function, you want to plus this number by 1, and then do a reciprocal of this number. Then that's it.
Oh, okay.
Yeah, it's always like that. Now, let's try the C. When they give you this one, the first thing you do is you change it to this, okay? Let's do the, use the trick I showed you just now. You leave a space in front. You don't write down number. And you take care x minus 2, you plus 1, right?
Yes.
And -2 plus 1 is -1. -1 reciprocal is negative, right? -1 reciprocal is -1. So you put a -1 in front, which will just leave a negative. Correct?
Yes.
But you want to always listen, please, please. I used to teach a student who is like those top students of one of the high school in Fobanesti. And in one very hard test, she didn't write down plus C for all this antiderivative. Even she get everything correct, her teacher take off her 30 points.
Wow.
She argued, but please, because without C and with C has really physical different meaning, so we cannot skip the C, okay?
Okay.
This is negative x to the power -1 plus C, all right? Okay. You can check, we definitely can check. X to the power -1 derivative is x. We use a power rule, okay? X to the power -1 is, derivative is -1, which is -2. But because here, you see here, this is 1 over x squared. Does that make sense?
Yes.
Okay. Now you can try this. I did teach you those kind of trigonometry stuff in summer. Now, before we do this, let's quickly review all the things we learned in summer, because all those question needs those kind of formulas. Sine theta derivative is what?
Cosine.
Cosine theta.
Negative sine.
Continue. Tangent.
Secant squared.
Good. Cotangent.
Negative cosecant squared.
And next is secant x, the secant theta.
Secant theta times tan theta.
Tangent theta times what? Secant theta. And cosecant theta.
Negative cosecant theta times cotangent theta.
Good. All right. So this part is not so hard. The hard part is the trig inverse. Okay. You remember we did this kind of thing. Y equals to sine, y equals to arc sine x. Remember? Yeah.
Yes.
We want to do this guy derivative. How do we do that? That's not easy. But we can do this. We can say, hey, x equals to sine y, right?
Yes.
And we do derivative for both sides. Cosine y times what?
Dy over dx.
Y prime, right?
Yes.
So y prime equals to 1 over cosine y, right?
Yes.
Now, x equals to sine y. Cosine y should equals to how much? You remember the trigonometry identities.
Oh.
So y equals to, so now y prime equals to 1 over cosine y, right?
Yes.
So this becomes to 1 over square root 1 minus x squared. Okay? The reason we have to remember this thing is because they are going to ask a question like this. Integral or antiderivative of 1 over 1 minus x squared dx equals to how much? You see? This is what? This is arc sine x plus c. That's the reason you have to remember that guy. If you don't know this guy, if you don't know this guy derivative this, you won't be able to figure out this, right?
Yeah.
Okay. Now let's continue finish your school stuff. Capital F is what?
It is
Sine theta plus c, okay? Now let's do E. Use the trick I showed you just now. Capital F is how much? Let's leave the 2 over 3 outside, okay?
okay.
Let's leave 2 over 3 outside. And then you do the, let's do the power rule. I ask you to plus 1 on the top, right?
Yes.
And you tell me this guy is how much?
7/4.
7 over 4. Then 7 over 4 reciprocal you put here. 4 over 7, right?
Yes.
Then this guy becomes to 8 over 21 times x to the power of 7 over 4. Makes sense now?
Yes.
Good. In this way, you can do it quickly, okay?
Okay.
Now, oh, please don't forget the plus C, okay?
Okay.
It's dangerous. Sometimes mean teacher take off a lot of points just because this. F should equals to what?
E to the power x
And
plus c.
yes, thank you. Now let's do the next one. All right. Yeah, this is saying the same thing. This guy is read as antiderivative, okay? Antiderivative of f with respect to x, okay? This symbol is called antiderivative of f with respect to x. So the differential dx, this guy, serves to identify x. So this means x is what? X is a variable, okay? This x is a variable of integration. If this guy becomes to theta, that means theta is a variable of integration, all right?
Okay.
Next, the other term, you might see, wow, this is like a new language class. You see so many different terminologies every day. This guy called as antiderivative. This guy is also called as a indefinite integral, okay?
Okay.
So this guy, we can also do this, okay? We can also, because when we do the f prime, capital F prime, we say, all right, I can also represent this guy by dy over dx, okay? Yeah, dy over dx equals to fx. So you can also see your dy equals fx times dx, okay?
Okay.
Now, that's the thing we teach just now. Now let's do this. Look at this. We can split this in two pieces. We can figure out this guy dt plus this guy dt, okay?
Okay.
So what do you think this guy should put what over here? Phi is copied down, right?
Yes.
And e to the power t, yes? Okay. And then plus. What do you think? This guy, when I take it out, what should I write down? What do you think? We reviewed this formula just now. Remember? We did this one just now. Who is that guy? You see? Who is that guy? Tangent here. That makes sense now?
Yeah, I think.
Okay. Now next one. This one. There are two ways to do this question. Okay, let's do the first way. Because your variable is x, it's respect to x. So we want to expand this one, okay? Let's expand this one. Make sense?
Yes.
So this guy should equals to what? Yeah. Tell me this guy, if you take out, what should you write down? Tell me your answer. How much? If you cannot write down in one step, it's okay. You do this. You do 9 times x to the power 2 plus 1 is 3. And then you do 3 reciprocal 1 over 3, right?
Yeah.
Yes? Okay.
Yes.
And then minus 6x, what do you want to write? How much?
Oh, negative 3x squared.
Plus 1, what you should write?
Plus c. 0. Oh, okay.
That 0 is for the c, okay? That 1 is for the x. That makes sense?
Yeah.
This question itself is the easy one. I'm going to teach you the use substitution later on. Okay, let's continue do this one. How do you do this one? You might want to divide them individually first. Okay, let me see your teacher give you any hard question. All right, so far this worksheet does not have very hard question. All right. Yeah, this part is going to be have the most difficult question for this semester. Okay. Now let's do this number 3. This equals Let's divide them individually, okay? How much is this one?
Negative.
Correct. Make sense? Now let's do user trick I teach you just now, okay? Use this kind of trick. Go ahead and wait for your answer.
Negative 1/2x squared.
Yes, very good. -1/2 times x to the power -2, yes?
Yes.
Because this guy +1 is this, and reciprocal of -2 is this. Now go ahead, next one. What do you get?
Negative 4/3 x to the power of -3.
Very good. You get so well now. Next one. Next one.
Negative 5/4 x to the power of -4.
Beautiful. Is that finished?
Plus c.
Okay. Now, this one. This one, you might wonder, how do I do this? Let's don't do radical. Radical is too confusing. Let's change everything to be exponential, okay? Let's expand this top first. All right,
Okay.
now go ahead. This equals how much? Let's do the first term.
X to the power of 3/2.
Okay. And minus 6x to the power what?
1/2.
Plus 9 times x to the power -1/2, right?
Yes.
Okay. Now let's get the first one.
Two-fifths.
Very good.
Oh, okay.
Minus it's okay. If you want to write down this extra step, you just do it, okay?
Okay.
Yeah, I would rather that you don't have any careless mistake, okay? Make sense?
Yes.
Okay. So that way we can change this guy to be full, right?
Yes.
Good. Next one. -1/2 plus 1 is +1/2. Reciprocal of 1/2 is 2, right?
Yes.
So this is 18. That makes sense?
Yeah.
Yeah, that's it. Okay. So let's summarize this type of question. When you have those kind of exponential stuff, okay? Yeah, even your denominator has a x, this like single term, just x. You can always expand avoid your numerator and then divide them single into this kind of format, and then use the power rule to solve this. Okay, so this type of question might be the easiest part for the antiderivative. Now let's see here. Oh, they ask you to match. Yeah, go ahead. Look for this guy. Who is this guy? Antiderivative.
Let's see.
Yes. Let's see the next one.
A.
Okay, they give you two easy questions because first term you already can tell.
Yeah.
Next one.
T.
Oh, this is too easy question. Okay. Now this one is B. Next one. Do you remember we said something like this? Ln x derivative is 1 over x, right?
Yes.
Okay. So which one is this guy? It's okay. Let's do this way. Okay. Yeah, let's do. When the question becomes more complicated, let's do from the right. Let's get this guy derivative. Fx, lowercase fx is f prime x. Okay.
Oh.
This equals what? This equals to how much?
2 over 2x minus 6.
Good. 2 over 2x minus 6. Continue. Simplify.
1 over x minus 3.
Good. Next one.
6x squared minus, 6x squared over 2x cubed minus 6.
Good. Chain rule.
Oh.
Okay. We can simplify this one. Okay. Let's simplify this guy by 3x squared over x cubed minus 3, right?
Yeah.
Let's do the next one.
2 over 2x.
Good. Which is 1 over x. Last one.
6x over 3x squared minus 6.
Okay. Simplify. Right.
Yes.
Now we can easily match. Okay. The first one is who?
G.
Good. Continue.
E. Then H. Then F. H.
Okay. Yeah, you see, if this way we want to do from the right to quickly get the answer. Okay.
Okay.
This is way more faster than doing from here.
Okay.
Next one. Okay. This is saying that this is an antiderivative. So you are going to match this. So what I'm going to do is I'm going to do this guy derivative. Yeah. If I do this left derivative equals to this guy inside, then they are going to match, right?
Yes.
Okay. Now let's get this guy derivative is how much? This guy derivative is 6 times sine 3x plus 4 times 3, right?
Oh, yes.
Because negative cosine is derivative is negative. Negative is positive. So this becomes to 18 sine 3x plus 4, right?
Do I just leave the 6?
So say it one more time.
Do I just leave the 6 and different?
Yeah, you leave 6 in front.
Okay.
Okay, so the coefficient number, leave it in front. This guy is matching to L, right?
Yes.
Next one.
Negative 6 sine 3x plus 1 times 3.
Okay. So it's negative 6 times 3, so it's 18. And then sine 3x plus 1, okay? Which is?
J.
Good. Next one.
6 cosine 3x plus 4 times 3.
Okay.
M.
Okay. Next, last one.
And then negative 18 cosine times 3x plus 1, which is K.
Which is K. All right, very good. Now let's do the basic integration rule, okay? Well, you can see here, if you have a constant value, your constant value differentiation is 0. That's why if you have 0, this guy is corresponding to C. Listen, I never ever see this guy equals to C. No, this guy equals 1 is corresponding to X derivative. So X derivative is 1. That's why if you have this guy, this is X, okay? Don't be confused by this, all right? And then you have to plus a capital C. That makes sense?
Okay, yeah.
You see here, K, oh, that's KX, okay? Yeah. If you have K as a constant term, you can take it out and take care of this inside, all right?
Okay.
If you have plus or minus, and then you do this, okay?
Okay.
And the general power rule. That's what we did just now. When you want to do the antiderivative, you plus 1 on the exponents, and then you do the reciprocal. That's it, okay?
Okay.
Yeah, so this is what we reviewed just now, which means we have to know those formula very well so that we can apply this formula correctly. Imagine if you don't know this, how do you get this? Okay. All of these are super important. Now, this is an easy one, no problem. That one and that one. This one is also an easy one. We already take care of this one before. This one is a tricky one. I teach you this before. Look. This equals to what? This equals to e to the power of ln and a to the power of x, right? Correct?
Yeah.
Because this guy, this ln e, this got 2, this means this just equals a to the power x. We have this rule, right? Yes. Logarithm rule. So if I want to, I don't know this guy's derivative formula, but if I treat this guy ln a to the power of x is x times ln a, correct?
Yes.
So I can write down e to the power of x times ln a. And then if I want to do this guy derivative, that's what? First, you treat e itself, you know? Yeah, this guy derivative, e to the power something is just the derivative is this guy. but you have to know the chain rule. X times ln A derivative is ln A, right?
Yes.
And then this guy is what? This guy is A to the power X. Okay, makes sense?
Yeah.
That's why when they have A to the power X dx, and you want to move the ln A to the denominator, because you can treat, if you write down ln A here, that's just A to the power X plus C, right?
Okay, yes.
Okay, that's what's going on. Yeah, you leave the ln A here, but you don't have ln A on the left, so you divide by ln A on the right, okay?
Okay.
Okay. Now we already reviewed this one. Based on this new formula, I believe they will give you some more tough questions. Let's see. All right, let's solve. Let's solve this one. So f prime x is 2x minus 1. So fx is going to equals to dx, right?
Mm-hmm.
So this equals what? Tell me, what's this? Is that x squared minus x plus c?
Yes.
Now, they give you f2 equals to 5. So 5 equals to 2 squared minus 2 plus c, right?
Yes.
So 5 equals to 2 plus c. C equals to 3. Okay?
Okay.
So that means our fx equals to x squared minus x plus 3. Okay?
Okay.
Yeah. That's called the initial condition. All right?
Mm-hmm.
That's called a general solution. You learned AP physics, you know this term already, yes? This is called the general solution. Given an initial value, this is called a specific solution. Okay?
Mm-hmm.
Let's go ahead to B. That equals to what?
Sine.
2 times what? Sine x.
Yeah.
Plus capital C, right?
Mm-hmm.
Now let's plug in the initial condition. F pi over 2 equals to 2 times sine pi over 2 plus C equals -3. So 2 plus C equals -3. C equals what?
-1.
-5.
Oh, oops.
Okay.
Okay.
Yeah, let's do D. C is easy, okay? Yeah, go ahead.
X
Go ahead, please.
cubed. Um, negative
X
2x squared
minus 2x squared
and then plus 2x
And
plus c.
okay. So we plug in this, okay? Equals -4. So that means -5. C minus 5 equals -4. C is +1, right?
Yes.
Okay. So you give the specific solution. Okay. Now let's do example of this one. GT equals to the antiderivative of t respect to t. So let's rewrite this to the exponential format. What you get? What's this equal?
2/3 times t to the power of 3/2.
Okay. T to the power 3/2, and then 2/3, and then plus c, right?
Yes.
Now let's plug in. You do see that calculus is using all the foundations that you learned for the all high school and middle school math, right?
Yeah.
Okay. Now you tell me this equals to how much? How much?
7.
This is 27. That's nice. So this equals how much?
18 c equals to 6.
So this is 27/3 is 9. So that's 18 plus c equals to 6. C is -12, right?
Yes.
Yeah, so you say, all right, my specific solution is over to the power 3/2 minus 12, all right? Okay, let's do the last one. Okay, what do you want to do?
Negative cosine plus c.
Okay. And next step, what do we do?
Negative cosine 0 plus c equals to 2.
Cosine 0 is how much?
1.
So -1 plus c equals to 2. C equals to what?
3.
Okay. So ft equals to 3 minus cosine theta. All right. Okay. Yeah. Your school don't really give any hard questions, but your school is supposed to give hard questions in the next few weeks. So let's see. The antiderivative for the inverse trigonometry is going to be really tough. So before you got confused, let's go ahead and run this kind of formulas. All right.
Okay.
Yeah. You see, because we did this in summer, that's why this formula comes to you very naturally, right?
Mm-hmm.
Now let's do this one. We already figured out the arc sine x, this guy. This guy is this, okay? So we can get that formula, all right?
Okay.
And the next one is y equals to arc cosine x, okay? And we do the same way. We use this implicit method, okay? We change x equals to cosine y, all right?
Okay.
So left side derivative is 1, right side is what? Negative sine y times y prime, right?
Yes.
So y prime equals to -1 over sine y. Okay. Now x equals to cosine y. Let's figure out sine y is how much. You see here, x squared is cosine square y. So 1 minus x squared equals to 1 minus cosine square y, which is sine square y, right?
Yes.
So sine y equals to square root 1 minus x squared. So that means this guy equals to -1 over square root 1 minus x squared. Does that make sense now?
Yes.
So if they give you a formula saying -1 over square root 1 minus x squared dx, this is arc cosine x plus c, okay? That makes sense?
Yeah.
Okay, now let's do the next one. We have y equals to arc tangent x. We do tangent y equals x, okay? Let's do the derivative for both sides. Left side derivative is what?
Secant squared.
Times what? Y prime, right?
Oh, yeah.
Equals to what? 1.
1.
Y prime equals to 1 over secant square y, right?
Yes.
Now let's figure out the secant square y is how much. Because this is respect to x, so we get the y, we have to convert it back to x, okay? So secant square y equals to how much? Trig identity, please. How much? Do you remember? Yes or no?
No.
Let's do this. This is critically important, okay? Yeah, for any value, if you have sine square alpha plus cosine square alpha, that's equals to 1, right?
Yes.
And you divided each term by cosine sine square alpha. Sine over cosine is tangent, so you got tangent square alpha. Cosine over cosine is 1. 1 over cosine is secant. Correct?
Yes.
Make sense?
Okay. Yeah.
So your secant square y equals to x squared plus 1. correct?
Yes.
In that way, your y prime equals to 1 over x squared plus 1. So that means if you have a 1 over x squared plus 1 dx, this is equals to arc tangent x plus c. Okay?
Okay. Yeah.
You see, now it's not going to be easy anymore, all right? Yeah. In the sine, cosine, secant, cosecant, tangent, cotangent, that part is not tough yet. But when we come to here, this is tough, okay? Well, the toughest one hasn't come in. Let's see here. Y equals to arc secant x. You say, oh my God, this is crazy. That means secant y equals to x, okay? Now let's do derivative for both sides.
Secant y times tan y
Yes.
equals to 1.
Okay. Now you have your secant y, which is x. You don't have your tangent y yet. So let's figure out the tangent y, okay? So secant square y equals to x squared. That means tangent square y equals to x squared minus 1, right?
Yes.
So that means this guy you have square root. Okay.
Okay. Yeah.
Well, if you choose calculus AB, they will not test you this, okay, for sure. But if you choose calculus BC, you have to do this, okay?
Okay.
All right.
Okay.
So that means you have the formula becomes more complicated. That's equals to what? Arc what?
Arc secant.
Correct? Yes.
Okay.
Now we haven't finished all of them yet. Let's do a y equals to arc cosecant. Okay. Yeah, you can do your own and then check with my answer together, okay? Got the same answer? Good job. You can also, you do this by yourself, okay? You can practice this one by yourself to find out that this guy, when you put a negative in front, you have an arc cotangent x, okay?
Okay.
Yeah, that's it. So I believe this thing will prepare you ready for what your school is going to cover in the next week. Okay. How is your test last time?
Oh, it was all right. I got a 91.
Oh, okay, not too bad. We can work even harder. Okay.
Okay, thank you.
Yeah, I'm going to send you this to your Google Drive. Okay.
Okay.
Yeah, today is kind of crazy. The iPad got uploaded to the 14th version, and then with Zoom together, when I share the screen, when I split this screen with Zoom, with this Google Good Notes apps and also Google Drive, it's going to stop sharing. So I'm not able to show you the Google Drive link together. I will do this after class. Okay.
All right.
Okay.
Thank you.
Thank you. Bye bye.